All right, question 15 here in section 5 of the first of the GRE practice tests. We get our first real word problem, I would say, on the test in this problem. I mean, yeah, there's been some words in previous problems like 12 and 11, but I think these don't really come across as word problems. I think what they're asking you and what they're giving you is fairly straightforward in these problems. Whereas in 15, I think translating the English into math is definitely not trivial. It's the kind of thing that can overwhelm students because you can learn how to do a specific problem, but then the next one doesn't feel anything like the one you just learned. So with that in mind, maybe we can go through 15 and really focus on strategies that'll work not just for this problem, but for whatever problem you see when you take your test. So first, I like to just read through the problem, understand what the hell we're being asked about. The total amount that Mary paid for a book was equal to the price of the book plus a sales tax that was 4% of the price of the book. Okay, fine. Mary paid for the book with a $10 bill and received the correct change, I would hope so, which was less than $3. Okay, so that's the first thing to notice. We don't know how much change she got back. In your head, maybe you think like $2.50 or something, but we don't know. It could have been 1 penny, it could have been $2.99, but it's kind of somewhere in that range. Then we're asked which of the following statements must be true. The price of the book was less than $9.50. The price of the book was greater than $6.90. The sales tax was less than 45 cents. Okay, our first problem is we're going to want to translate this into math. Unfortunately, there's several things that we don't know. I mean, I guess there's a lot of things we don't know. We don't know what book she got, but we don't care about that. There's several things that are relevant to this problem that we don't know. We don't know the cost of the book, but that'd be awesome if we did know that because that would help us figure out whether A and B are correct. And then we also don't know the sales tax. That'll be relevant for figuring out part C here. If you go back to this problem, we also don't know how much change she received. I-E, E-I, I never remember that one. I guess it should be E-I, right? I before E except after C, except that's not always true. I don't know. English is the worst. Whatever. There's lots of things we don't know that we're going to need to figure out. The reason I really want to highlight what we don't know at this point is because we're going to end up using a variable, typically the letter X. And we have to decide what X should represent. You can solve this problem letting X represent any of these unknown quantities. But that doesn't mean that it doesn't matter what you choose for X. Some choices of X will answer the question more directly and save you some time. What I think makes the most sense is to let X represent the cost of the book. The reason why is because 2 of these 3 choices directly relate to the cost of the book. And if I know the cost of the book, I can figure out the sales tax really easily because the sales tax is just 4% of the cost of the book. So since these 3 things all either directly or indirectly can be evaluated if we knew the cost of the books, I would choose X to represent the cost of the book. Now that we've decided what we want our variable to be, we can go back and reread the problem, trying to translate each of the different sentences into math. So the total amount that Mary paid for a book was equal to the price of the book plus a sales tax that was 4% of the price of the book. So focusing on this point, the price of the book is X, and then the sales tax is 4% of the price of the book. So I got the price of the book plus 4%, so 0.04 or 4 divided by 100. If I didn't have a calculator, I'd probably write this as 4 divided by 100 because fractions generally are easy to deal with when you don't have a calculator. But since you're lucky enough to get a calculator on this test, maybe you write it as 0.04x. When you're looking at word problems, the word of often means multiply. The word is typically means equals, and often means plus. Anyways, this expression right here represents what Mary paid for the book. So what do we know about what Mary paid for the book? Well, she paid for the book with a $10 bill and received change. What that means is this expression right here must be less than $10, right? She got money back. If this expression was more than $10 and she paid with the $10 bill, she'd be stealing, and Mary isn't stealing. She got the correct change back. How much change did she get back? Less than $3. So think about what that means. That means she must have paid more than $7, right? If you're paying with the $10 bill and you get less than $3 back, you must have paid more than $7. So we have this compound inequality, which we can solve for X, which will allow us to answer these different statements. I think for most people, setting up this inequality is the hardest part of the entire problem. So if you struggle to get here, know that you're not alone. But if you can get here, I think you're in pretty good shape. So how do you solve this inequality? Well, the idea is we want to kind of get the X all by itself. So now we have an X and a 0.04X in the middle of our compound inequality here. So we could add those together. I have one of these X's plus another 0.04 of these X's. So in total, I have 1.04 of these X's. It's It's worth pointing out that you might have jumped directly here from the information in the problem. You might recognize that 1.04x is the cost of the book plus another 4%, aka the sales tax. If you have the ability to start here, great, save yourself a step. The good news is we've changed from having two x's in the problem to a single x. The bad news is we still haven't isolated this x. To isolate this x, we have to divide by 1.04. If you had an equality like 1.04x equals, 30 or something, you'd probably be pretty comfortable solving this equality, right? You'd divide both sides of the equation by 1.04 and get that x is 30 divided by 1.04. We're going to do more or less the same thing here with this inequality. It's just now there's not two sides of an equation. There's three sides of a compound inequality. So we're going to divide all three of these by 1.04. So I get 7 divided by 1.04 is less than x is less than 10 divided by 1.04. And you're like, oh, you can do that? That's really easy. You can always just divide by whatever number's right here. Well, no. You can only do that if this number is positive. When you have equalities, you can just divide by this number and not worry about it as long as it's not 0. But when you have inequalities like we do here, you have to make sure this is a positive number. If this is a negative number and you do that same step algebraically, you're going to get an incorrect answer here. In the case that this is a negative number, you have to flip these inequalities around. This becomes greater than and this becomes greater than. In this problem, this is a positive number, so you don't have to worry about all that, but that's really important. It's a very common mistake people make when dealing with inequalities, whether they're compound inequalities, you got two of them like you do here, or just regular inequalities like this portion of it. If you multiply or divide both sides of an inequality by a negative number, you have to flip that inequality around. Anyways, at this point, we pull out a calculator and figure out what is 7 divided by 1.04. It looks like that's about $6.73. And then we figure out 10 divided by 1.04. Looks like that's about $9.61 or 62 cents. I don't think a test like this would try to get you on rounding errors, so you're probably fine to round this to the nearest penny or just truncate so that you're left with the nearest pennies. I don't think it would make any difference at all for this test. But if you want to be really careful, you could round to 3 decimal places so that you can really see what's going on, even though there'll only be 2 significant figures in the problem. So I could say that x is greater than $6.731 and less than $9.615. I think we now have all the information we need to answer this question. You're like, do we? I don't really feel like we do. Well, remember that x is representing the cost of the book. So what this is telling you is that the cost of the book is less than $9.615 and more than $6.731. So this first statement says the price of the book was less than $9.50. No, that's not true. The price of the book could have been $9.61, right? $9.61 is less than $9.615. So this first statement that the price of the book must be less than $9.50 is incorrect. It could be less than $9.50. It could be anything between these two bounds right here. The price of the book was greater than $6.90. No, that's not true either. The price of the book might be $6.74. That's entirely possible. $6.74 is more than $6.731. Okay, what about statement C? The sales tax was less than 45 cents. Well, unfortunately, we haven't figured out any information about the sales tax over here. We figured out information about the cost of the book. But we know that the sales tax is 4% of the cost of the book. If I take this compound inequality here and I multiply all 3 of these values by 0.04, I'd get 0.04 times 6.731 is less than 0.04x is less than 0.04 times 9.615. First, note that that's completely legitimate. I can multiply each of these things by 0.04 because this is a positive number. If this were a negative number, I could not go multiplying all these things by that value. I'd have to flip the inequalities. But because this is positive, it's perfectly legitimate to do that. Inequalities work just like equalities when you're adding or subtracting to both sides or when you're multiplying or dividing by a positive number. The only time inequalities don't work like equalities is when you're multiplying or dividing by a negative number. So maybe now you agree with these steps mathematically, but you're still a little bit confused about why we did this. Well, recognize that 0.04x right here is the sales tax. So this statement tells me information about the sales tax. I know that the sales tax must be more than 0.04 times 6.731, whatever the hell that is. It must be less than 0.04 times 9.615, whatever the hell that is. How do I figure out what the hell those are? Calculator time. I can take my 9.615, which is still stored in here, and multiply that by 0.04. And then I can take my 6.731. You could argue that really I should use this value or this exact expression. But again, I don't think you're going to run into any rounding error issues on this test. So 3 decimal places is plenty to keep. Multiplying that by 0.04, I get 0.269. So let's see, maybe over here, what I figured out is 0.04x, which is my sales tax, is greater than 0.269 and less than 0.385 if I round to 3 decimal places. With this compound inequality, I can evaluate the validity of statement C here. The sales tax was less than 45 cents. Yeah, absolutely it was, because this is the sales tax. What this compound inequality tells me is that the sales tax was between $0.269 and $0.385. It's less than $0.385. It's certainly less than 45 cents or $0.450. This is a true statement and the answer to the question. I guess I've been shading in correct answers, so sure, I'll do that. At the start of this video, I made the point that you don't have to make the cost of the book the X. I just think it makes it the easiest to choose your unknown to be the cost of the book. But you absolutely could have let your variable be the sales tax or even the change received or probably even some other unknown in the problem. But I think what you'll see if you try making one of these your unknown is the problem gets a lot more difficult and you essentially end up solving for the cost of the book anyways. Hopefully when you look at these choices here, you saw that the price of the book is what you really want to know about, and that would be your big hint that this should be your unknown. So maybe it's not worth your time for me to show you how you could solve the problem if you had chosen sales tax or the change received to be your unknown, because it gets pretty messy. But I do want to make one more point. On problems like this, where you have these inequalities, if you're super uncomfortable solving these compound inequalities, you can also just consider the kind of extreme cases. I'm a little bit low on room. Maybe I can squeeze this in down here. So what do I mean by extreme cases? Well, Mary paid for this book and she got some change back. And all we know about her change is that it was less than $3. So I guess what that means is her change was at least a penny, but less than $3, so at most $2.99. You could probably do $0 and $3 to make the math a little bit easier for you, but I think technically, since it doesn't say less than or equal to $3, we should say $2.99. Let's see, if her change was 1 cent, that means she paid $9.99 in this extreme case. Or in this extreme case, she paid $7.01. But we don't care about what she paid, we care about the price of the book. And we know she's going to pay the price of the book plus 4% of the price of the book. What I'm saying is if she paid $9.99, then 1.04, I don't know, C maybe for the cost of the book would be equal to $9.99. Or in this extreme case, 1.04 C, which I used X for up here, would be $7.01. Solving these for C, the cost of the book, I get that the cost of the book in this extreme case is $9.99 divided by 1.04. And in this extreme case, the cost of the book is $7.01 divided by 1.04. I stick those two numbers into my calculator and I get essentially the numbers you see up here. I don't want to use my calculator again, but you can check this if you want. This would be about $9.61, and this would be about $6.73. If you don't like these inequalities, you can consider extreme cases, which is really just evaluating the endpoints of these inequalities, but it might make more sense to you intuitively, right? She got less than $3 back. How much did she get back? I don't know. Maybe 1 cent, maybe $2.99. Most likely some number in between the two of those. You consider these extreme cases and you figure out that the cost of the book in this extreme case was $9.61 and the cost of the book in this extreme case was $6.73. Since these are the extreme cases, I can use these extreme cases to evaluate these statements. The price of the book was less than $9.50. No, in this extreme case right here, it was $9.61. That's false. The price of the book was greater than $6.90? No. In this extreme case right here, the price of the book was only $6.73. That's also false. Figure out how much sales tax you paid in these two cases? Well, let's see. In this case, I paid $9.99 and the price of the book was $9.61. So $9.99 minus $9.61. What is that, like 38 cents in sales tax? In this case, the price of the book was $6.73, but I paid $7.01. So the 701 that I paid minus the 673 that the book cost is what, 28 cents if I'm doing that math right in my head? What I'm saying is that in this extreme case, sales tax was 38 cents. In this extreme case, sales tax was 28 cents. The sales tax was less than 45? Absolutely it was. It was something between 28 and 38 cents. Just like I figured out, up to a rounding error, over here. All the study manuals are going to tell you that you need to solve a compound inequality to solve this problem. And I mean, that's essentially true. However, if you really hate inequalities, on problems where inequalities would naturally arise, just to consider the extreme cases instead, and you'll come to the exact same conclusion.